an analysis perspective, what we have is logistics engineers who will go off and perform here at KSC for the ground systems a logistics spares analysis. So that logistics spares analysis, so what it entails is working with engineers to review the drawings, go over then what also the operations, working with the operators to understand what the system is going to do. And so then the logistics engineers, they analyze for example, the reliability from a development and engineering perspective. They analyze the reliability or predicted reliability of the parts that make up that system to try and understand how long a part is expected to last. That information can be challenging to get. A lot of the times in most industry, when they develop mass parts, they will develop a reliability standard for those parts. But for a lot of the work we do here, where it's low number of parts, just many parts, but few of each of those parts, a lot of times it's difficult to come up with a good reliability number. And so in many cases, then we have to try and work with the engineering to figure out an anticipated reliability. And so reliability then is kind of coupled with operation time. So every system is going to be operated for an expected number of times, for an expected length of time. And so one of the difficulties then, particularly now on a new program like GSDO, is trying to understand, okay, well, what is that operations time? Because a lot of times what you have from the reliability perspective is you have, okay, well, this part is reliable for X amount of hours before it's expected to fail. Well, what is that X amount of hours is also then a difficult challenge a lot of times from us to try and figure out. So if in working with the engineering and the operators, then the logistics engineers does the best they can to estimate, okay, well, now this is the expected failures that we can anticipate for this particular system. And what they do then is in their analysis, they'll in this particular case, it takes the form of a particular document, but they'll outline what their expected failures could be. And then based on what the expected failures that they anticipate, they say, okay, these are the parts that we think need to be spared for that particular system. And this is when we think we need to procure those spares based on the lead time of those spares and when we think the anticipated need for those spare parts could be. Normally, for every system out here, the engineering, the operators, they will get together and they will develop a failure modes and effect analysis for all the particular systems that are used here at KSC. So what we do from a logistics analysis and engineering perspective is we take that output that they generate and trying to say, well, these are the different failure modes or expected failure conditions that we can see for this particular system. And we try and take that into account whenever we try and then determine, okay, well, what are the spares that we need based on that failure mode or the effects. And so that's usually, that output is what we work then with, again, coupled with the engineering, the reliability part that we have to try and determine, okay, this is what we think needs to be procured from a spares perspective. From a EEE parts perspective, one of the things that we have to, again, it can be a challenge for here at KSC from what we do. We look at the different parts that are being designed and developed by the engineers to try and determine what we need from a sparing perspective. A lot of times then the engineers will determine, okay, are they going to use EEE parts whenever they're designing their system, or is it parts that are custom for their purposes? What we try and figure out a lot of times is, well, what is the supply chain look like for those parts? For a lot of the EEE parts, they come with robust supply chain initially, but for a lot of those EEE parts, they usually don't have. We can expect that obsolescence becomes a big issue for EEE parts and all electronic parts in general after 5 or 6 years or so. That's usually the life cycle of an electronic part. And so really what it does from our perspective is we say, okay, well, EEE part is good because we know what the performance of a EEE part is in many cases. We can determine what the reliability is, but we also know that those parts are going to require some analysis for obsolescence probably within a 5 to 6 year lifespan. From a counterfeit part perspective, what we do vigorously try and work to ensure that we don't get any counterfeit parts. For every part that we receive here at KSC, there's always going to be some sort of quality inspection that's done at the part. Usually what we do is when the procurements are initially placed, the quality inspection requirements for that particular part is also listed on that procurement. And so what we do is that whenever we receive that part here at Kennedy Space Center, we review that quality inspection requirement to make sure then that the part that we actually ordered matches what we were anticipating. And so there is a lot of protection to try and make sure that we don't receive any counterfeit parts, usually done by our quality and quality inspectors here at KSC. The quality portion of the procurement documents, they usually list what the inspection requirements are. And so we have here quality inspectors that are part of the quality group, as well as within the contracts that we write that have procurement. They also have a quality function associated within the requirements to make sure that they also provide additional quality inspection. So that whenever we do receive the parts, and receiving the parts means essentially not just accepting them on the dock, but accepting them on the dock as well as then evaluating to make sure that they are what we wanted before they get put into our inventory system.